All right, guys. So now we're going to talk about transformations of exponential functions. In the previous video, I kind of just gave you an introduction, and now we're going to go ahead and perform some transformations on these exponential functions. So what I have here is just what we'll call a parent function. You got f of x is equal to 3 to the x, and we're going to take that, and again, we're going to do different types of transformations on this function. But first, I have it graphed over here. You can see that I have f of x equals 3 to x graphed. And we're going to talk about the different characteristics of f of x equals 3 to the x. And if you recall from the previous videos, the domain of this is going to be all reals. Now we know that because this is going to go forever to the left and it's going to go forever to the right. So it's covering all of those x values. Then we had what we talked about was the y-intercept. And we can see that the y-intercept here is at 0, 1. Then we had the horizontal asymptote. And I'll abbreviate it after this. And that is at y is equal to 0, which is the x-axis. It approaches the x-axis but never actually crosses over. And then we talked about the range. And of course the range, it starts just about at 0, but again, it doesn't touch at 0, but right above 0 and all the way up to infinity. So y is greater than 0. So now we're going to see also when we do these transformations, how does that affect these different characteristics that we have here? What's going to change when we do these transformations? So let's look at the first one. And we have g of x is equal to 3 raised to the x plus 1. So now what we have is this change right here. Well, what does that do? So that plus 1 up in the exponent, that is going to shift f of x. Remember, f of x was our original function, which is 3 to the x. It's going to shift f of x equals 3 to the x 1 unit to the left, which you could probably see that in red over here. That has shifted all of these points right here. It shifted them all over 1 to the left. So if you notice here, you have a plus 1, but we shifted to the left. So if you actually had a minus 1, if you had something like 3 to the x minus 1, that would then be a shift to the right, 1 unit. So you're basically going in the opposite direction of the sign in this case. All right, well, how does that change those characteristics? Well, the domain is not going to change at all. It's going to be all reals. In fact, for all of these, it's just not going to change. None of the transformations are going to change the domain at all. Then the y-intercept. So did the y-intercept change? So it was over down here and moved up to here. So it was at 0, 1, and now it is at 0, 3. So this is one of the characteristics that definitely changed. What about our horizontal asymptote? I'm abbreviating it HA now. That has not changed. The left-right shift is not going to change that, so it's y is equal to 0. And our range is also not changed, so y is greater than 0. So basically what you have, a left-right shift is going to only change the y-intercept. All right, let's take a look at the next one. So here we have h of x equals 3 to the x minus 2. So that minus 2 is not up in the exponent. So what does that cause? So that, and you can probably see it from the graph, cause a shift of f of x, which of course is 3 to the x, 2 units down. So now you see we're following the sign. This is a -2 and we're actually going down. So yes, if you had a +2, you had 3 to the x plus 2, that would be a shift up 2 units. All right, so let's see how that changes the characteristics with a shift up or down, in this case, down 2 units. So again, our domain is not going to change. Domain is all reals. And then we have the y-intercept, which we can see is now down here at 0, -1. So that is something that changed, one of the characteristics. Then we have our horizontal asymptote. Now look what happened. You see that this was the horizontal asymptote for the parent function f of x equals 2 to the x, but now we shifted down 2 units, and that shift will definitely change the horizontal asymptote, and of course that's going to change the range. So now our horizontal asymptote is at y is equal to -2. It shifted down 2 units. It's directly tied to that up-down shift. And then our range is now y is greater than -2. So look what happened. All 3 of these changed. All 3 of these characteristics changed. The only thing that didn't change was the domain. So basically an up, down, shift will change all characteristics. Running out of room here. I'll just abbreviate that. Or except domain. So all characteristics, that stays in there. Sorry, jumped up because I hit the page number. So all characteristics except the domain is going to change. All right, so let's look at the next. So here we have -3 to the x. So k of x equals -3 to the x. And looking at the graph over here, you could probably see that it definitely is going to cause a reflection. So it's going to be a reflection of f of x, which is of course 3 to the x, over the x-axis. So what is that going to change in terms of our characteristics? So domain, nope, nothing's going to change there. Domain is still going to be all real, still goes forever to the left and forever to the right. Then we have our y-intercept. Well, that is now here, which is at 0, -1, so that's going to change. The horizontal asymptote, well, that hasn't changed, because you can see that's still here. We just reflected it, so this is still y is equal to 0. Now, I will say that it's because we don't have an up-down shift with this. So you can have multiple shifts. You can have a reflection, then you can have a left-right shift and an up-down shift with one function. Well, because this doesn't have an up-down shift, when we just reflect it, it's not going to change the horizontal asymptote. So this one is, we'll start over here, is a special characteristic because it won't change if you don't have an up-down shift, but it will change with a reflection if you do have an up-down shift with it as well. And then the range here is now y is less than 0. Got to be careful with that. This is now starting from here and goes all the way down. So it is now less than 0. So what changes, these two characteristics definitely change when you have that reflection over the x-axis. And this one is really, it depends if you need an up-down shift as well in order for that to change. All right, and the last one we're going to look at here, we got j of x is equal to 3 raised to the -x. Now, I did this in the actual introduction to exponential functions, but we'll talk about it again. So what this does, and hopefully you can see that it is a reflection in the y, or over the y-axis. So this is a reflection of f of x equals 3 to the x over the y-axis. So everything is going to, if you recall from the introduction video, all the characteristics are going to stay the same. This doesn't change any of those characteristics. So this is going to be all reals. And then we have the y-intercept, 0, 1. That doesn't change from the parent function. Horizontal asymptote is also y equals 0, and the range is y is greater than 0. So hopefully this will help you with transformations. Again, you can have multiple transformations in one function. I just covered each one individually, and I don't want the video to be too long, but you would just go ahead and follow along where you have. So for instance, if this was a -2 here, you would have a shift down 2, and then of course you would have the reflection over the y-axis, and so on, whatever you have here. So I'm gonna stop this video here, and the next video, it's kind of in line with exponentials. I'm going to talk about interest. I'm going to talk about interest in the next video, which naturally follows after covering exponential functions. So I will see you on the next video.